Hello, Keith Rucker here at VintageMachinery.org. Guys, so today I'm over here at my Monarch Model K lathe. This has been a lathe that has been my good old standby, get her done lathe that I've been using in the shop now for quite some time. Shortly after I built the shop, I acquired this machine. When I got it, we kind of went through it, did some repair stuff. I rebuilt the saddle and the cross slide and the compound and all that on it. We did some cosmetic cleanup to it, repainted it. Made a few repairs to it along the way, and this again really has been my workhorse machine as far as lathes are concerned in the shop for quite some time. But there's been a problem that I've had with this machine that I've just kind of been tolerating, and the time has come that I need to fix it. The reason that it hasn't been a huge problem is it has to do with the taper attachment on this lathe. Now the taper attachment is an attachment. It's not all lathes have them. It was an optional attachment. You can get them. This one has one on it, but it enables you to turn a taper on the lathe. Normally when you're turning your work to be parallel to the bed, parallel to the spindle and the tailstock to keep it with a uniform size going up and down. But sometimes you need to make a taper. You need to make something that's at a taper where it goes in and out. And I seem to be doing a lot of taper related projects here lately. I need them for this, that, or the other. And I've actually got some tapers that I need to turn coming up. And whenever I kind of redid this lathe, shortly after I put it back together and started using it, I realized that there was a problem with the clamp that kind of holds the taper attachment in place, where it has, I think, was broken at some point and never really repaired properly. And what is happening is that when you use a taper attachment, you kind of clamp this back piece in the back, and I'll show you this in a minute. And there's a clamp that mounts to the bed, and when you move the carriage, it keeps the taper attachment stationary, and basically your cross slide is moving in relationship to whatever taper you have that set to. That clamp is very important because that's what holds this back piece steady. The clamp on mine had just a little bit of play in it, so that whenever you kind of went into, I would go out, and whenever I started coming back into a cut, it would kind of pull forward just a little bit. Now once it got tight, yeah, it worked. The taper would be fine, but it was kind of finicky, kind of had to have a couple of extra inches of travel in your work to kind of account for that little bit of play that was in there. And when you start doing real precise tapers, it was just giving me some problems. The time has come, we're going to fix that. So let me kind of show you the problem, show you the part that we got to work on, and I think I've got a way we can fix it. We're going to give it a shot and see if we can try to get this thing fixed like it needs to be. So the people that watch the channel regularly, I'm sure, have seen the taper attachment before and had it explained, but in case you're not familiar with this, let me just real briefly talk about it. So again, up underneath these little slides here is this bar. This bar is adjustable. It's on a rack and pinion. You can come in here and loosen this up. Let's see. And you can basically adjust that to whatever angle or taper that you want, and then using that, once you get it in place, you lock it down to that taper. You lock this in. Normally this clamp is loose. It just kind of moves with the carriage, but when you lock this down and you tighten up a bolt in here that basically connects the cross slide to this, what happens is that this section back here is going to be held in place by this clamp. It's not going to move, but it's going to slide on this piece here, and when it does, this is directly connected to the cross slide. You can't use the handle in the front anymore to move it in and out, but it's going to follow this angle, this taper, whatever it's set to, rather than following the ways down there. The carriage is still following the ways, but the cross slide is moving in and out to kind of smoothly follow this taper. It's a really nice feature for cutting tapers. here's the problem I've got with mine. It has to do with this clamp down here. This clamp has got a problem with it, and it's not clamping it tightly, and whenever you start moving it, it's wiggling. And I think I'll move the camera around because you can see it better from a different angle. Whenever I move the carriage, again, this clamp's going to hold this steel. It's going to follow along that piece. So if you look here, you see it's following along, and it's actually moving toward me. Here's the problem, the clamp. See how it's got just a little bit of wiggle in it? Now, I can come out to the end of my cut, and then whenever I start back in, it's got a little bit of flex in it. Now, once it kind of gets under load, it holds fine, but there at the beginning, it's just got that little bit of wiggle in there, and that has just really been aggravating me. It's not a game changer. It's not a end of the world situation. I can work around it. I have worked around it, but it's not ideal either. We need to fix this clamp. Let's take it off and see what the problem is. Tell you what, before we do take it off, just a close-up look at it so you can kind of see it. That little bit of wiggle. And I've had people comment in my videos about that. They've seen it. Yeah, I've known about it, but like I said, I just kind of lived with it and worked around it. So there's a couple of screws here. Use a spanner wrench to loosen this up. There we go. And there's a clamp there that goes all the way through that clamps it from the bottom. Just go ahead and take that off. So here's the problem. On the bottom side of this, we kind of got this little notch in here, and there's a lip on this other side that kind of hooks over the ledge there, and it captures it in place, and when that ledge is proper, it keeps it from twisting. The problem is that that ledge is mostly gone. I don't know what happened. I see marks in there where it looks like someone milled it off. Why? I don't know. It should never have been milled off. It should have been a nice, tight, snug fit on there and kind of hooked over the top of that. But the way it is now, it looks like it's maybe a 1/16 of an inch, maybe less than that, and it's just, over the years, it's worked itself where there's a little bit of play in there. There's not enough of a lip to catch there. So here's what I'm going to do. We're going to take this to the milling machine. I'm going to mill this completely out, actually mill a little slot in there, and we're going to put a new piece of metal in there that will actually hook in there, capture on the back, and that will hopefully take that out. And when this was new, it was made that way. Modified it sometime in the past. I'm sure there's a story behind it. I don't know what that story is, but to make this thing work properly, we're going to have to fix it. So now, guys, the challenge is getting this thing set up in my vise where it is flat and kind of working off the original surfaces. This is a rough casting, so there's nothing on here machined except this bottom surface that we need to work on. When it was done originally, they just kind of machined it, clamped it, machined it, but I got to get this thing clamped up where it's true to those surfaces. So I'm going to sweep the bottom of this. It's kind of the best surface I've got to work off of, it looks like, right about in there. And this is not a perfect surface. There's clearly where, I'm just going to stop that right there. I got my dial on 0. I'm going to sweep it from one end to the other, and we're going to see about where we are. And well, it dips down in the middle. It's not flat across the bottom, but we're 0 from one end to the other. Now, let me see, I'm going to come back out. Now I want to sweep from end to end. So we'll just, I think it's that zeroed out. All right, so now I want to do a sweep into the back. a good bit. I'm going to take a hammer and kind of bump this around a little bit. See, it needs to go the other way. All right, I think I got this thing pretty well dialed in. I have swept across the bottom. I've swept it front to back down here. And then I've also swept across this face. And that's your 3 axes to get this thing trued up. Now, every one of these surfaces has got ups and downs and dips and stuff. It's a worn surface, but they're all measuring within probably 3 or 4 thousandths maximum. And the way this thing is working, I mean, it's just a clamp down here on the end. If it's off whatever, it's not gonna, it's got room for adjustment, so it doesn't have to be absolutely perfect, at least in relationship to out here. The notch needs to be pretty much perfect, and we're gonna be kind of redoing that. So I think as I do this, I will go ahead and remill this inside surface, go down just a little bit deeper. Again, where this thing is positioned is not gonna be that critical. What is critical is we have everything the correct size. So now what I think I'm gonna do is come in here, I'm gonna put an end mill in. I'm gonna notch out a little piece down here in the bottom, and then we're gonna put a piece in back in there to get that ledge on there. We will then remachine all the surfaces, get it to the right size, and go put it back on the machine and test her out. So let me get set up with an end mill, and I will see if we can start doing some milling here. And I got an end mill set up in here, and what I want to do is I want to just kind of notch out a little piece. I want to go a little bit below this surface, and I'm actually going to come a little bit to the inside of this surface because we're going to remachine this bottom and that edge, and I just want to make sure I got enough material in there when we do that. So I'm just going to go ahead and start nibbling it out. All right, I just dropped my end mill down kind of flush to the top there. I'm just going to make a pass across there to kind of start out with. Just barely touched all the way across. And I'll go about 25 thou. Raise the table up. Cut across. A little bit of a lip there. Go about another 25 thou down. I'll tell you what, I'm gonna go in a little bit deeper this direction. All right, so doing some quick measuring, the lip needs to stick up 1/8 of an inch, 125 thousandths high, and I think I want this lip to be 125 thousandths deep. That'll give me a piece 1/4 inch thick that we'll put in there. So I want to see where I'm at on the depth right now. And I've just got a depth micrometer. And see, we're at 90 or 75, so we're at 81 thousandths deep right now. And I want to go to 125, so I'm going to take that a little bit deeper. I'm going to do it in 2 passes, so this will be 20 thousandths deep. And that's 44. Yeah, I'm about 2 thousandths shy of where I wanted to be, but this close enough for what we're doing right now. Now I need to find me a piece of stock to go in here that's about 5/8 inch wide, 1/4 inch thick, and about 3 inches long, and see if we can get it in there. Let me see if I can find a piece of metal to go in there. All right, I had a bar of some cast iron stock. This is Durabar, they call this extruded cast iron material. This is about the right thickness. It's a little bit thick, but we can mill that off once we get in there later. And I cut off a piece that's 3 inches long, or a little over 3 inches long, which again fits in there, but of course it's way too tall and it's all rough machined. So it's just bandsaw cut basically. So what I need to do is I need to mill a flat on the top of this, and that will come down in here. And I also need to cut a piece off of it that that's going to be, well, it needs to be a little over 1/4 of an inch thick. And then we can start working on fastening that. Then we'll machine it all in place once it's fastened. But of course, this is way too tall right now. Since I got this set up on my milling machine here, I think I'm going to go over to my Kearney Trekker 2D mill and do those milling operations over there, just so I don't have to tear this setup down to mill on this one. One of the advantages of having an extra milling machine in the shop. So I got this set up over here on the 2D. This is the Kearney Trekker Model 2D milling machine. I'm going to raise that up until we start touch off there. I just want to get a flat milled across the top of that piece of metal. Let's mill across. We're not making complete contact. I'm going to raise it up a little bit, come back across. And I think that cleaned up. That end mill's about the same size as the width there. I'm just going to go, I move the table toward me. I'm just cleaning up that back side, and I'm going to come back across this front side and just clean up that little bit of edge. All right, that's got the bottom side milled flat. Now I think I need to get this cut a little over 1/4 of an inch thick. Probably, I don't know, I'll probably just trying to think what I'll do. I'll probably just do it on the bandsaw, just rip it, and then we can, and I probably need to mill one side of this flat. I may just go, we may just put it in the mill there and mill one side flat there too. Just thinking this out as I go. All right, we'll just work our way across that. All right, that's got that pretty well flat on two sides. That'll give me something to work off of. Now I need to rip it to the proper thickness. So I went ahead and just ripped that on a bandsaw, and I just sanded it top of it. We're going to be machining all these other surfaces. I'm not worried about cleaning them up right now because we'll machine them in place after we get this mounted. Right now I do want to go ahead and get it mechanically attached, and we're just going to drill and tap a 1032 hole through here. That's roughly in the center right there. I'm going to do 3 screws and 2 dowel pins holding it all together. Again, the screws will just kind of clamp it together. The dowel pins will keep it from twisting. I want to get this first one done here. So let's fire up. I'm just going to drill this all the way through. And then I'm going to This is for the tap size of a 1032 5/32 drill bit. Through the top piece, and now we're drilling down through the main casting, and I'm going to drill it all the way through. All right. Now what I think I'm going to do is I'm going to countersink these so that a flathead screw will go down below the surface there, because we're going to have to mill the top of this anyway. And so I'm going to go countersink that, and I'm going to actually drill it out oversized where the drill bit will go through it. Let me go do that, and then we'll tap this, put it all together. Once I get the first one in, we'll go ahead and drill the other ones and get everything else put in place. So I'm not going to show this. I'm just going to, like I said, I'm just going to drill this out to the proper size for the clearance of the screw to go through and countersink it. I'll be right back. Got a 1032 tap here, set up with a tap follower right in line where we just drilled, so that'll make sure that tap goes straight down that same hole. I don't like the way that tap feels. I'm going to go grab a different one. That one feels dull. I grabbed a different tap here. Let's see if this does better. Oh yeah, all the difference in the world. Life's too short to break a tap. The tap gets dull, throw it away. Just going to lightly deburr that. There's our countersunk hole in there. Here's our screw. I'm going to get some Loctite, put down in there, and bolt that together. Put a little dab of Loctite on the screw. Drop that down in there. All right. All right, that head will be below the surface, so I don't have to worry about milling that off as we mill this to the proper height. That's in there nice and tight. I think I'm gonna go ahead and put my, let me think about this. Okay, I'm gonna put 2 more screws, one on the end, and then I'll put a dowel pin in between them. And that's probably overkill, but nothing too strong ever broke, right? Now we got our tab mounted in here very securely. I got 3 screws that are countersunk below the surface, holding it all together. And on the other 2, what I did is I just drilled them out. I just tapped them all the way through since it was already all the way down. I didn't worry about having to drill that out. Countersunk it in place, did everything right here in place, never took that part back off again. Loctited everything in, so this is pretty well permanently mounted. Now I am going to put some dowel pins in, but I think that's going to be my last step because I want to get the height decked off and all that. I don't want to put my dowel pins in, and then those are hard and I don't want to hit them with an end mill, so I'm just going to wait and do that last step. What I want to do now though is we want to kind of make this inside piece the correct width and everything. I am going to start by coming down to the bottom. I'm going to just clean up this bottom. I just want to touch it all up, make sure that it's flat. I noticed when I was measuring with the indicator, it had a dip in the middle. I go ahead and flatten it all out. Next, I'm going to come in, I'm going to just touch the back edge back up there where it's square to the bottom. Again, I just want to clean it up. I don't want to take off any more metal than I have to. Then we will come over and cut this width so that it is the correct width to fit down on there. And last step, we'll deck the top. I say last step. We'll deck the top. We'll have to trim the back of it off, so on and so on. But we're just going to kind of work our way through here. So let me get the end mill down here at the bottom, and we'll start down there. All right, we'll fire up. I'm just going to raise my table up until I'm just barely touching. Again, I don't want to take any more metal off of these surfaces than I have to, but I know they need to be cleaned up. Man, that pretty well cleaned up. Bring this up against that shoulder till we touch the back. All right. Take a few more thou. It's barely in here. Maybe take a little bit more. That's going to be good right there. Yeah, we're cleaning up all the way down into the bottom. All right, I just squared the back face to the bottom. Now I'm going to come to this other side, and I'm just going to barely touch that side, just enough to clean it up, and then I'll get a measurement and we'll take it to the right size. All right, so the slot over there, or the little top piece, is 1.25 inches, 1.250. So I'm going to measure this, and right now we're about 1.246, or excuse me, 1.244. I've got 6 thousandths I need to take out of there. So I'm just going to zero out my digital readout. I'm going to take. What I'm going to do is I'm going to take, I think, 5 thousandths. I want to just kind of sneak up on it. And I need 3 more thousandths to go. All right, I'm about 1 thousandths over, which is exactly where I want to be. So next thing I need to do is deck the top of this. That needs to be 125 thou. We should have plenty of metal there, and that's sort of just a rough surface right now, but we're at about 250 thousandths high. So I got about 150 to take off of it. So right now we're at basically 200 thousandths. So I've got 75 to come out roughly. I'm gonna do another 25. All right, 1, 125, right where we need to be. So I need to clean up this back edge. It just needs to kind of be flush with the casting. Got a 15/64 drill bit in there, which is one size under 1/4 of an inch. We're going to drill these out and then ream them to just slightly, a 1/2 thou under 1/4 of an inch, and then we're going to put a 1/4 of an inch dowel pin in there. And the idea here is the dowel pins are going to be just a press fit in there. There's going to be no room for any kind of movement or anything. So the lateral forces of this thing twisting will go to the pins and not to the screws. The screws are just going to be pulling, keeping it pulled together. The pins will take the lateral stresses. That's the game plan. So, all right, hole number 1. And this will ream it to size. All the way through. All right, I think we got our machining done. I'm going to go take this over and test fit it onto the lathe, and then we'll press our dowel pins in. So this has got to fit on this ledge. Oh yeah. That fits back and forth. It slides. And no noticeable side-to-side movement. Of course, that will clamp together as well. So, all right, I think we're ready to put our pins in and let's reassemble this and try it out. All right, I'm going to put a little this Loctite for press fits here on these pins just for good measure. Same thing over here. Get started. And we'll go over to the press and press those in. I'm just going to go press them in flush and we'll have these done. Pins are in, not quite sticking out the end, which is good. We're going to go ahead and get this all put back together. This is our clamp up under the bottom. Now, before I do anything else, I want to make sure this is going to slide in place, because when it's loose, it just kind of floats around. I'll make sure we don't get it so tight that it won't slide easily. Tighten up my retaining. All right. All right, so it is not clamped currently. Yes, and it slides just fine. That's what we want. And then when we clamp this down, that should be locked in tight now, and we shouldn't see any movement in it, hopefully. Oh yeah, all the difference in the world. All right, I am super, super happy with that. I'm going to loosen that back up. And I'm going to loosen this back up as well so that the taper is not engaged. And I think we got this knocked out. Well, guys, I am super stoked to have this problem fixed. This has been a problem that's been plaguing me for quite some time. And like I said, it hasn't been impossible to work around. I have worked around it, successfully worked around it, but it's just been aggravating. This should make my life much easier, and I've got some taper turning coming up here real soon I'm gonna be doing, and I really needed to get that knocked out, and it is now. So, guys, with that, that's a wrap. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments, they really help out a lot. Big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. All those are really good ways to kind of go a little bit above and beyond and help out around here. If you really feel like you're getting good value out of this content, please consider chipping in a little bit extra, even if it's just $1 or $2 a month. Enough of you do that, it makes a huge difference. And with that, guys, we're going to sign off. We'll get out of here. We'll catch you on the next video. Again, as always, thanks for watching.